Good morning to one and all present here. I am Trisha Thakkar from Abu Dhabi Indian School, Branch 1 Al Wadba, and today I will be talking on the topic Understanding Python Data Types. So, what are data types? Data types in Python refer to classifying or categorizing data objects based on their characteristics and behavior. They define the type of values that variables can hold, and they determine the performed operations on those values. Python has several built-in data types. This includes numerical types such as int, float, and complex numbers, strings, booleans, and collection types. Each data type has its own sets of properties, methods, and behaviors that allow programmers to manipulate and process the data effectively in their programs. Numeric data types. Numeric data types in Python are used to represent numerical values. There are three main types of numeric data types. The first one is integer. Integers are whole numbers and they do not have any decimal points. They can be either positive or negative. Floating point numbers, also known as float. Floating point numbers represent the decimal values. These contain decimal points. Complex numbers. These numbers are used to represent numbers which have a real and an imaginary part. They are written in the form of a plus bj, where a is the real part and b is the imaginary part. Boolean data type. This represents either true or false, and it is used for logical operations and conditions. It is important to understand that the word true and false should have the first letter capitalized since Python is case sensitive. String data type. This represents a sequence of characters enclosed in single quotes or double quotes. And finally, we have the collection data types. These include lists, tuples, and dictionaries. Now I will be explaining each one of them in detail. Starting with lists. A list is a consecutive sequence of characters which is enclosed or surrounded by single or double quotes. Triple quotes are used for strings that take up multiple lines, and anything that is in quotes is printed as it is. So, for example, the string over here is apple, and since that's in between the quotes, it is printed as it is. Indexing in a string. Accessing individual characters of the string by using the subscript or the index value is known as indexing in a string. Each character in a string is located in different slots, and there are two types of indexing. The first one is forward indexing. In the example given over here, the word we have is Python. Each letter of the word is assigned a specific index. In the forward indexing, it starts with the value 0. So the first character of the string is assigned the value 0. Over here, P has the value 0. The second character has the index 1, and so on. The second type of indexing is backward indexing. This indexing starts from -1 till the length of the string. Over here, the last character, which is n, will be given the index -1. The second last character, which is o, is given the index -2, and so on. Traversing a string. Traversing a string means accessing each character, one after the other, by iterating through the elements of a string. And this is done using either the for loop or the while loop. Iterating through the for loop. The code for this is if s is our string, which is given the value Python, for I in s, print I. How this works is I takes the I takes the value of the first character, which is P, and it prints I. This is iterated, and in the second iteration, I takes the value as Y, and so on, till the entire string is traversed and printed. Iterating through the while loop. This also gives us the exact same output, but the while loop is used over here. So the code for this is I is equal to 0, and while I is less than the len of S, it prints the S of I. And to make sure this loop continues, we have to add the statement I is equal to I plus 1. So over here, the value of I is 0, and the len of S is the number of characters in the string, which is 6. And so it iterates till I is less than 6, and all the letters are printed. String operations. The different string operations in Python are concatenation, repetition, membership, comparison, and slicing. The concatenation operator. The creation of a new string by adding two different strings is called concatenation. The plus operator is used to join the strings. Over here, variable A is Python and B is programming. This is concatenated and its value is stored in another variable, which is C. When we print C, it gives us the output Python programming. Next, we have the replication operator. This is used to create a new string by repeating multiple copies of the same string by using the replication operator. A is equal to Python, and when we print A into 3, it prints the same string 3 times. Next, we have the membership operators. These are the two operators which are used to check whether a particular character exists in the given string or not. These operators are in and not in. The in operator, it returns true if the character or substring is present, and if it is not present, it returns false. Whereas the not in operator returns true if the substring does not exist in the given string. Over here, when we print h in hello, it gives us the output true, as h is present in hello. But in the second example, when we type capital H not in hello, this is also true, as it is very important to remember that Python is case sensitive, and the capital H and small h are not the same thing, and they have different values. Comparison operators. Relational operators can be used to compare two strings. This includes the greater than, greater than equal to, less than equal to, or not equal to signs. Python compares the strings using their ASCII values. And the most common ASCII values used are 0 to 9 is 48 to 57. This means the ASCII value of 0 is 48, the ASCII value of 1 is 49, and so on. The values of capital A to capital Z are 65 to 90, and the values of small lowercase a to z is 97 to 122. In the example given, it says print arrow is greater than Aaron. So basically how the comparison works is it checks the ASCII values of each and every character until there is a different ASCII value which can be used for comparison. The first letter of both the words is A, and so their ASCII value is the same, which is 65. The second letter of both the strings are also similar, which is R. The third letter is R in arrow and O in Aaron. Over here, the ASCII value of R is greater than O, and so the output is true. String slicing. This is used to retrieve a subset of the values of the string. Chunks of characters can be extracted from the string using the slice operator with two indices in square brackets and it is separated by a colon. The syntax for this is string name and in square brackets, start colon end colon step. If our string is hello world and we want to print only the word hello, we can do this by using the string slicing, which would be print a of 0 to 5. This prints only the characters which have the index 0 to 5, which is hello. Now I will be talking about different inbuilt functions that are present in strings. Each data type in Python has its own functions. So the first function over here is len, and this is used to return the length of the string. So in this string, which is hello world, if we print len of a, it counts the numbers of characters present in the given string, and we get the value as 10. Capitalize function. This method returns the exact copy of the string, except for the fact that the first letter will be in uppercase. So if our string again is hello world and we print a dot capitalize, the output would be hello world, but the first letter would be capitalized. Note that only the first letter is capitalized of the string and not the sentence. The split function. The split function breaks up a string at a specified separator, and it returns a list of substrings. The syntax for this is string.split, and the separator is written in brackets. So if our string over here is apple, banana, orange, and we print x.split with space, it gives us a list of the separate substrings, which is separated by commas. Replace function. The replace function replaces all occurrences of the old string with the new string, and its syntax is string.replace old comma new. In this example, if we write x.replace apple comma banana, it would replace the word apple with banana, and the result would be banana, banana, orange. Next, we have the find function. This function is used to search for the first occurrence of the substring in the given string. This method returns the lowest index of the substring if it is found in the given string, and if it is not found, returns -1. The syntax for this function is string.find substring, comma, start, comma, end in parentheses. In this example, we have taken the string as Python programming. In the first example, print s.find prog. Over here, it checks for the first occurrence of the substring prog, which is at index 6. In the second example, which is print s.find p, 4, 10. Over here, it starts checking for the substring p only after the fourth index, which is from O. This is why the output is 6 and not 1, and not 0. And the last example is print s.find L. And since L is not present in the string, the output is -1. Now I'll be talking about the index function. This function is similar to the find function as it does the same thing. It searches for the first occurrence and returns the lowest index of the substring. What is the difference between the find function and the index function? It raises an exception if the substring is not present in the given string, whereas in the find function, it gave us the value -1. So the example over here is the same as before. When we print s.indexprog, it gives us 6. And when we print s.index p, 4, 10, it also gives us 6. The only difference here is in the last example. When we print s.index of L, the output will be a value error. The next function I'll be talking about is the isDigit function. This function returns true if the string contains only digits. And the syntax for this is str.isDigit. The title function. This returns the string with the first letter of every word in the string. And the difference between the title function and the capitalize function is that in the title function, it capitalizes the first letter of every word. But in capitalize function, it capitalizes only the first letter of the entire string. So it doesn't matter how many words are there, only the first letter gets capitalized in the capitalize function. Count function. This function returns the number of times substring str occurs in a given string. If we do not give the start index and the end index, it takes the start index as 0 and the end and ends at the length of the given string. The syntax is str.count substring comma start comma end. A few more functions are the lower function. This function converts all the uppercase letters into lowercase letters. The isLower function. This returns true if all the letters in the string are in lowercase, and if they're not, it returns false. The upper function. This function converts all the lowercase letters in the string into uppercase. IsUpper function. This function returns true if all the letters are in uppercase, and if they are not, it returns false. And the last function for strings is the isSpace function. This returns true if the string contains only white space characters, which includes the spacebar, the tab key, etc. Lists. A list is a collection of values or an ordered sequence of values and items. The elements in a list can be of any type, such as strings, integers, objects, etc. The values that make up a list are called its elements, and these are separated by commas and are in closed brackets. Lists are mutable. That means that lists can be changed according to our wishes. Indexing in a list. A list contains a collection of items which are stored according to its index. Like strings, any item in a list can be accessed using the slice operator, which is the square brackets, by specifying its values. These indices start with 0 and are equal to the length of -1, and similar to the string indexing, these are also of two types. We have the forward indexing and the backward indexing. Forward indexing starts from 0 and goes up to the length of the list, and then backward indexing starts from -1. Traversing a list. Traversing a list means accessing each element of a list, and this is done by three ways. Using the in operator inside the for loop. The code for this would be for I in L, print I. Over here, I takes the value of each element in the list and prints it one by one. Using the range function. For I in range, len of L, print L of I. So first, Python checks the len of L, which is 5 over here. And then the value of I is 1 to 5 until everything is printed. And the last way is using the while loop. This is also similar to the string traversing. Over here, I is equal to 0, and while I is less than the len of L, we print I and increase the value of I by 1. This gives us the output 1, 2, 3, 4, 5, which is the list. Operations on lists. Like strings, certain operations can be performed on lists. These are concatenation, repetition, membership testing, indexing, and slicing. Concatenation operator. This is the creation of a new list by adding two different lists, and it is done by the plus operator. In this example, we have two lists. A is equal to list of 1, 2, 3, and B is equal to list of 4, 5, 6. We create a new list, which is C, by concatenating operators A and B, and this gives us the output which combines both the lists into a new one. Replication operator. This is used to create a new list by repeating multiple copies of the same list, and it is done with the multiplication operator. Over here, when we print A into 3, it prints the list 1, 2, 3 three times. Moving on, we have the membership operators, and these are used to check whether a particular element exists in the given list or not. The in operator returns true if the elements are present, and the not in returns true if the elements are not present. In this example, which is the list containing values 1, 2, 3, 4, 5, when we print 1 in A, it is true as the first value of the list is 1. And when we print 2 not in A, it is false since 2 is also present in the list. List slicing. List slicing is used to retrieve a range of elements from the list. Chunk of elements can be extracted from the list using this operator. And the syntax for this is list in square brackets start colon end colon step. The example over here is if we would like to retrieve a sublist containing the values 1, 2, 3, 4, 5, the code would be A brackets 0 colon 5. And this would slice the main list for us to provide us a list with the values which we want. Similar to the strings, lists also has its own built-in functions. And I will be discussing a few of these built-in functions. The first function is append. The append function adds a single item to the end of the list. It does not create a new list, but it modifies the original list. This item can be numbers, strings, another list, a dictionary, etc. This is possible in lists as list is a mutable value, but this cannot be used for strings or tuples. The syntax for this is list.append and item in parentheses. So over here in the list, A is equal to 1, 2, 3, 4, 5. If we would like to add 6 to it, the code would be a.append 6. The extend function. This adds one list at the end of another list. In other words, all the items of a list are added to the end of an already created list. The list is not formed. There is no new list formed. It's just modified. And the syntax for this would be list1.extend list2. In this example, when we type the code l1.append l2, all the values of the list2 are added to list1. The insert function. This function can be used to insert an element or object at a specified index. This function takes two arguments: the index where the object is supposed to be inserted and the object itself. So the syntax for this would be list.insert index comma value. In this example, we have inserted the value 100 at the index 2. And so the statement for that would be l.insert 2, 100. Reverse function. The reverse function in Python reverses the order of the elements in a list. It replaces a new value in place of an item that already exists, and it does not create a new list. So over here, if we have the list 1, 2, 3, 4, 5, a.reverse would print 5, 4, 3, 2, 1. The index function. This function returns the index of the first matched item from the list. It returns the first occurrence of the item, and if the value is not present, an error is generated. The syntax is list.index of item. And in this example, when we print a.index of 2, the output is 1, since the index of 2 is 1. Deletion operation. Python provides several ways to delete an element or a group of elements in a list. There are many different methods for this. If the index is known, either the pop function or the del statement is used. If the element is known but not the index, the remove function is used. And to remove more than one element, the del statement is used with list slicing. Pop function. It removes the element from the specified index, and it also returns the element which has been removed. So the syntax for this would be list.pop of index. In the given example here, we have the list, and when we enter the statement l1.pop1, it returns the value that has been deleted, which is 2. But then when we print the list, it prints the list without the value. This proves that the value is deleted. The del statement. Del statement removes the specified element from the list, but it does not return the deleted value. In the list, L is equal to 10, 20, 30, 40, 50. When we delete L of 3, it deletes the value which is present at the third index of the list. And when we print the output, it gives us 10, 20, 40, 50. The del statement with slicing. This can be used to delete multiple elements from a list. And the syntax for this is del L in brackets start colon end. Over here, if we would like to delete the values that range from the index 2 to 4, the statement would be del L of 2 to 4. And when we print it, it would give us 10, 20, 30, 40. The remove function. The remove function is used when we know the element that has to be deleted, but we do not know the index. And so the syntax for this is list.remove element. When we code the statement l.remove 20, it removes the element 20 from the list. And the output remains 10, 30, 40, 50. Now I will be talking about another data type, which is tuples. A tuples is another sequence data type, which is similar to the lists. And this also consists of multiple values separated by commas. The difference between lists and tuples is that tuples are enclosed within parentheses. Also, another difference is that lists are mutable, whereas tuples are not. The characteristics of tuples. They are ordered. Tuple elements or items are arranged in an order, and this order cannot be changed. They are immutable. Tuples are immutable or unmodifiable, and once you create a tuple, there is no way that you can add, change, or update its elements. Permanent duplicate values can be inserted in tuples, and tuples are heterogeneous in nature. This means that tuple can hold values of different data types. Operations on tuples. Similar to the strings and lists, the different operations on tuples are concatenation, repetition, count, indexing, and slicing. Now we'll be looking at the built-in functions that are present in tuple. The len function is similar to the len function in strings and lists, which gives us the length of a tuple. The count function over here is used to count the the number of occurrences of an item in a tuple. So, for example, we have the tuple over here. T is equal to 1, 2, 3, 4, 2, 2 in quotes, and 56. When we print the statement T dot count 2, the output is only 2, as, uh, as there are only two values which are numeric, and the third one is a string. Next, we have the any function. This function returns true if a tuple is having at least one item. If the tuple is empty, it returns false. That means if over here we have an empty tuple, which is just the brackets, and when we print any of t, it is false. The min and max function. The min function returns the element with the minimum value from the tuple, whereas the max function returns the element with the maximum value from the tuple. In the given example, when we print max of t and min of t, the output is 5, 1. The sum function. This function returns the sum of all values in a tuple. And this method works on numerical values only. For example, t is equal to 1, 2, 3, 4, 5. When we print the sum of t, the output is 15. This is used to make our numerical calculations easier using tuples. We have the sorted function. It is used to sort the elements of a tuple, and it returns a list after sorting and does not modify the original tuple. The default sorting is done in ascending order. In our given tuple, when we print sorted A, it gives us a list of the elements arranged in ascending order. It is important to understand that the output provided is a list and not a tuple, since tuples are unmodifiable. Now, I'll be talking about dictionaries in Python. In Python, a dictionary is an unordered collection of items where each item is a key value pair. We can also refer to a dictionary as a mapping between a set of keys or indices and a set of values. The key value pairs are enclosed in curly brackets. The syntax for this would be curly brackets, key, value. In this given example, the first element of the dictionary is A 10. The second element is B 20, and the third element is C 30. Characteristics of dictionary. Each key maps to a value. The association of a key and a value is called its key pair value. However, there is no order defined for these pairs, and so the dictionaries are unordered. Each key is separated from its value by a colon. The items are separated by commas, and the entire thing is enclosed in curly brackets. The keys are unique and immutable. Keys are unique within a dictionary, while the values are mutable and can be changed. Next, it is indexed by keys. This means that the elements in a dictionary are indexed by only the keys and not the relative positions or indices. So you cannot access the elements of a dictionary using the indexes. You can only access them using their keys. The value of a dictionary can be of any type, but the keys must be immutable data types, such as strings, numbers, or tuples. This means that keys cannot be lists, since lists are mutable, but values can be anything you want it to be. And finally, dictionary is mutable. We can add new items, we can delete items, or we can change the value of existing items in a dictionary. Thank you so much for joining this session, and I hope you learned a lot about the different